Hi guys, my name's Hayley. I'm one of the educators with Keep Australia Beautiful New South Wales EnviroMentors program. It's a very long name, I know. And we're going to be going through our landfill experiment today. If you don't have the landfill booklet, you can email me here and I'll send one through to you. Now, I'm on Gadigal land today, so I would like to acknowledge and pay my respects to elders past, present and emerging from the Gadigal people of the Eora Nation. We're looking at taking care of our environment today, and it's the same as caring for country. There are lots of different ways we can achieve this. All right, now the booklet is aimed at stage 3. But the experiment itself, it can be adapted stage 2 up to stage 4. Before we get into it, the reason we're looking at it is because of where our waste goes, all right? So we need to think about what happens to our waste at home. If you live in an urban or suburban area, you've probably seen these bins before. Now, we generally have a recycling bin. This can be yellow lidded. Some people have a blue bin. Some people, like Victoria, for example, they've got a purple lidded bin. Now, recycling, you do need to check out your local council's websites for exactly what can go in each of these bins, because different local councils around the state and around the country have different rules as to what goes in the bins. Recycling, all of this stuff picked up in the back of the recycling truck, it's taken to what we call a MRF, and they sort out those materials to be processed into new things. We have a green bin. It might be a garden waste bin. It might be a FOGO bin. So FOGO is an acronym. It stands for Food Organics, Garden Organics. Now that means things from your garden like grass and leaves. If it's a FOGO bin, you can also include your food scraps in there. But as I said, you need to look up your local council's bin rules. Some people don't even have a green bin at all. So all of that stuff goes in the red bin. Now the red bin is general waste, garbage or rubbish. Lots of different names, but this is the bin that ends up going to landfill, okay? So all of the stuff you pop in your red bin, it's not going to be sorted out. For recycling, it's going to end up in the landfill, which is what we're looking at today. So our landfill experiment, we are going to be replicating a landfill on a much, much, much smaller scale. So you're going to need a few things. You're going to need an empty washed out bottle. Now 2 litres is best. I think this is 1.5 and it's going to go all the way up there. You can use a clear bottle. You can use a milk bottle. We've got much larger holes at the top. You might not be able to see what's going on during the month, but that's all right. It's still going to work. You're going to need a texter, a ruler, some scissors. You're going to need adult help or adult supervision because we are going to be chopping some things up, and you may even have to definitely get an adult to help you cut out the top of a bottle if it's too small. I did this very easily with scissors, but you do need an adult to help you there. You're going to need different kinds of waste. So we need some food waste, organic waste. I've just got the tops and the peels of what I had for morning tea. I'm not going to use nice fresh fruit in there. We also need dirt from the garden. This is an old pot plant of mine. The reason we like it from the garden is because it has lots of microbes in it that will help all of that matter in your little landfill to decompose. So decomposition is the same as rotting. And our different materials, so different sorts of things that might end up in a landfill. Paper, newspaper, napkins, metal, so we're going to use aluminium foil, things like old pie tins or old dip lids, That's fine, just give them a little rinse. Plastics, soft plastics is best just because you can squish them down a bit easier. Now I do want to stress that I don't want you just putting new things in your landfill experiment. I want you to grab things that you would have been throwing out or recycling anyway. So we're repurposing them for our experiment. I also like to use cartons because this is a combination of materials. We have plastic on the outside, cardboard in the middle. If it's long life, it will have a layer of aluminium foil and another layer of plastic there as well. Your parents might have some coffee cups, especially at this time when we can't use our reusable cups, and they'd be a good substitute for a carton if you don't have any. Cardboard is great as well. You might even want to collect little things like the tops of cans. If you want to use something different, like a piece of an old plastic toy, that's cool. Things we can't put in here, yucky, germy things, we can't put like bits of meat or cheese because that becomes dangerous for us because it's going to rot and attract the wrong sorts of microbes, bacteria, and it's really going to stink. All right, so none of that. You're also going to need a paper or an opaque bag that fits in the bottle, that fits over your bottle. We're going to use this to keep it sort of dark in there to simulate being underground. We don't get sunlight in a landfill. Now, if you have a bottle with a very small top, you can also use a funnel to get things in instead of cutting it open, but you'll just need to chop things up a little bit finer. Alrighty. Now a landfill, the word in itself is very descriptive. It's a compound word, landfill. We quite literally fill land with rubbish. So there is a lot of engineering and planning behind it. We don't just dig these great big holes everywhere and start filling them up. We do need to keep them safe so the stuff buried in the landfill can't leach out and get into our waterways and our groundwater. But they do essentially, I'm not going to read this whole thing out, I'd like you guys to go through it. We do essentially get these layers of rubbish underneath the ground, and that's what we're going to simulate in our experiment. Now, because these things are rotting underneath the ground, there's not a lot of air down there, if any. So they're rotting in what we call an anaerobic environment, anaerobic. You might have heard of aerobic, like aerobic exercises involving breathing, oxygen. Anaerobic is the opposite, where we have little or no air. So they rot in a very different way. And they produce a gas called methane. Now, methane is a greenhouse gas. It's actually 20 times worse than carbon dioxide. We don't want lots and lots of landfills producing this methane gas. We also don't want lots and lots of landfills just because if we're throwing valuable resources in our landfill, like paper or metals, things that can be recycled, we're wasting that resource. It's just going to be buried underneath the ground and we're going to have to go chopping trees down or mining to get this resource again to make new things where we could have just recycled it in the first place. All right. This is a scientific inquiry. It's a month-long inquiry, so we'll have our setup, we'll write our hypothesis, and then we're going to let our landfill do its thing for about a month. Okay, so we're using, and you may have heard of this, cows moo softly to help us set up a fair experiment. So cows, we're going to change one thing, and that's the types of rubbish, the materials. We are going to measure the decomposition of the rubbish. It's just observational measurement for this experiment. If you wanted to scale it up or down and weigh the different things, go for it. And we're going to keep everything the same, everything else the same. So all of the conditions in our little landfill will be kept the same, and that's quite easy because it's all contained. So that's a nice easy one for us. Now, the reason we do this to create these fair tests is because we want to know what is affecting our experiment. If, for example, you wanted to test a new kind of fertilizer and you thought, okay, I will put this fertilizer or plant food on one plant and see if it grows more than another plant, and use the height of the plant as your measurement, but you have one plant in the sun and one plant in the shade, you're actually not going to know whether it was the fertilizer or the amount of sunlight that affected the growth of the plant. So all of your measurements, all of your results, they would not be valid, okay, because there are too many variables going on. So when we do our scientific experiments, we need to control these so we know what caused the outcome. Before we set up our experiment, or just after, that's fine, we need to come up with our hypothesis, okay? So we have these different materials and we need to think about what's going to happen to those materials. So a hypothesis is a prediction of what's going to happen using past knowledge. So you might know something about composting, you might know something about what these different materials are made out of and how they break down. So you'll have a great hypothesis. So you might say, for example, my hypothesis is at the end of the month, I will still have big chunks of passion fruit skin in my landfill, but my plastic would have fully decomposed. Okay? Try and do a bit better than that. I'm not going to tell you the answer. You need to come up with a hypothesis. And if at the end of the experiment your hypothesis was not correct, that's fine. That's part of the scientific process. We still learn a lot when we disprove ourselves as well as proving ourselves, okay? All right, before we put everything together, it's a really good idea to take a photo of your materials. So at the end of the experiment, you can compare them to what's happened. Because our memories aren't always that great, especially in lockdown. So it's a good idea to have that visual aid before you start putting things in and setting up your experiment. Alrighty. Now, we are going to make sure our pieces of rubbish are about the same size, and that's because we're trying to keep this element the same, okay? Because if I had a really big chunk of orange peel and a tiny little piece of paper, that wouldn't be fair, because the little piece of paper is definitely going to rot or decompose a lot faster than that big chunk of orange. So we do try to make all of our materials about the same size. You are going to need to measure 3 centimetre, you see the reflection, 3 centimetre increments up your bottle, because we are going to put 3 centimetres of dirt, rubbish, dirt, rubbish, dirt, rubbish, dirt, rubbish, dirt. Now, the other day I tried this and I was just using a marker to mark my bottle, and then I found when I put the dirt in, I couldn't see my mark. So I've got some little sticky things on there so I can see it as I fill it up. You can use masking tape. You could even put masking tape up your bottle to help you out there, or rubber bands around the bottle if you've got things like that at home. It doesn't need to stay there for the whole experiment. It's just to help us fill it up. All right. I'm going to start, like in a landfill, with a layer of dirt at the bottom. Use gloves if you want to. It doesn't bother me, so I'm not going to. We do, of course, at the end of the experiment, need to wash our hands, or setting up the experiment rather. But I do hope everyone's washing their hands lots and lots anyway. You might want to do this outside or with some newspaper on your kitchen bench, because my bench is getting a little bit dirty here. All right, so I've got 3 centimetres of soil at the bottom. Now in each layer, I'm going to put different kinds of rubbish. So I'm going to put every kind of rubbish in every layer. And that's another way of ensuring our test is fair. So they're all in very similar conditions. Right before I do that, I'm going to put a little bit of water in the bottom. I'm just going to use a cap because it needs to be a little bit moist in there to help decomposition. If you have a spray bottle, a water spray bottle, 2 sprays, that's great. All right, so in here, 3 centimeters of rubbish. So a bit of carton, cardboard, another bit of cardboard, paper, aluminium foil, plastic, orange, passion fruit, strawberry, orange, passion fruit, strawberry. All right, so right up until my next line. So I'll keep going there. All right, looking beautiful. So 3 centimeters of that rubbish. So don't worry if it's slightly uneven, that's going to happen. And we're going to keep going up. The next layer will be my dirt again, up to my next marker. That's a lot of dirt. Mess everywhere. Now you can see things might be hidden from you, but you can see little things going on. So after my next layer of dirt is in, another little bit of water, and we will keep going up until we are finished. Done. Maybe better. All right, so our last layer at the top is the dirt, and we will put water. And that is that. You can notice in mine that I can't see all the distinct layers because the little bits of dirt have sort of traveled down. That's okay, it's going to be fine. Then I put my paper bag over the top, and I'm going to put this on a sunny windowsill. That is so it gets nice and warm. If you still have, for example, you haven't cut the top off like I did, don't screw a lid on, because as I said before, look how dirty my desk is. As I said before, there are going to be gases forming as things decompose. Have you ever taken a bottle of milk out of the fridge that's off and it's all like puffy and hard? That's because there are gases forming in there that are trying to escape, but they can't. Now this shouldn't get stinky because we're just using fruit and veggie peels. If your parents are worried, you can put it in a sheltered outside position. Now we're going to leave this. We can have little looks. We are going to make sure it starts, we're going to make sure it stays a bit moist because we do need some moisture in there to help with the decomposition. If it dries out, it's not going to be very effective. So every couple of days, have a look. Just touch the top very lightly, and if it feels wet, you can leave it. If it is a bit dry and you can't see like any condensation around the bottle, give it a few sprays or a few capfuls of water. Alrighty, so at the end of the month, we are going to compare our materials to what they looked like from those photographs you took at the beginning. So at the end of the month, you're going to cut the bottle open, you're going to tip it out, maybe outside on some concrete or on a table that you've prepped with some paper to clean up all the mess. And we're going to see which materials rotted down the most and the least. So if you can't find any single piece of plastic in there, it means it has completely rotted or decomposed. Okay, If the materials are a lot smaller, they've sort of shrunk, it means it's decomposed a bit. So visual observations, those photographs, you can put the colour of the different scraps, what they looked like, were they shiny, were they dull? Any feeling, did it feel different? You might say it felt crunchy or squishy or sharp. Not sharp, don't use sharp stuff towards the end of the month. All right, so at the end of the month, the same observations, the colour, has the texture changed, those sorts of things. So for this part of the experiment, I would recommend either wearing gloves or making sure you don't start going through it and then touching your face. It's not like the grossest thing in the world, but still we do need to be careful. You're then going to write up your results. So we need to know which items decomposed the most and which items decomposed the least. Then in your own words, did this support your hypothesis? So is this what you predicted would happen to the materials in your little landfill? All right, now in your booklet, there are also follow-up questions. You can, of course, research if you're not sure of the answers. Just make sure you use a good site, a reputable site. If you're using the internet, you can ask your teachers or your parents sometimes which looks like a good site that you're actually going to get correct information from or not. Now, as I said earlier, if this doesn't support your hypothesis, that's okay. If your prediction was wrong, you learned something, and that's what science is about. It's all about learning. All right, guys, have fun with your experiments. I hope you enjoyed this little video, this super high-tech video. If you have any questions, if you'd like to share any photos of your experiment with us, or again, if you'd like that little science booklet that goes with this experiment, my name is Hayley. Give me an email at education@kab-nsw.org.au. All right, enjoy, stay safe, and happy sciencing. Bye.